So now we have this parsing table for SLR1 parser. Now let us see the tracing of an input string, that is let us assume it as left parenthesis x comma x right parenthesis. So it looks like the grammar looks like validating an ordered pair of two numbers. So this is a particular example that we are going to see. So now you have three columns: stack, and you have input, and you have the action. Okay. So in the stack, initially you will have on the left end you will have dollar and you have 0. Initially you will have 0. Here you have left parenthesis x comma x right parenthesis and then the right hand marker dollar. Okay, so 0 on left parenthesis, 0 on left parenthesis, it is shift 3. So the action will be shift 3. Okay, so that means you need to have 3 on the stack, 0 3, and this left parenthesis will be gone. So you will have x comma x right parenthesis dollar. So now we have 3 on x, 3 on x, you will have shift 2. So that is action is shift 2. So that is here 0 3 2. Here you have comma x right parenthesis dollar. Now 2 on comma, 2 on comma, you have reduction using the first production. So that is s gives x. If you so that is s gives x, production using s gives x. Okay, so I'll write reduce s gives x. So now while seeing the while reducing, we have to find the right hand side. So right hand side, what is the right hand side? There is only one symbol. So how many symbols are there on the right side? Those many states has to be removed from the stack. So you have 2 will be removed, 2 will be popped off this stack, and you will have 3 on top. So 3 on what is the left hand side? That is s. So you need to find the go to of that. Three on s, you will have 3 on s, you will have 5. So that is 5 here. So 5 has to be pushed down to this stack. After removing 2, you have to push 5. So that is $0 3, 2 will be removed and 5 will be added. So it will be 5 here. And here you have comma x. So now we have to see on 5 on comma, what is that? 5 on comma, you will have R3 here. So R3 is L gives yes. So reduce L gives yes. So right hand side one symbol, that means 5 has to be popped. So that is 3 there. So go to 3 comma then left hand side, that is L. 3 on L you have 4. So that is 4 there. So 5 has to be popped, that is right hand side only one symbol, so one state has to be popped and 4 has to be pushed. So that is $0 3 4. Again here it is comma x, right hand side, right parenthesis dollar. Now 4 on comma. 4 on comma, you have shift operation, so that is shift 7. That means $0 3 4 7, and since it is a shift operation, this comma will be gone. You have x, right parenthesis dollar. Now 7 on x, 7 on x, you have shift operation, that is shift 2. So it is $0 3 4 7 2, and x will be shifted, so you have dollar, sorry, right parenthesis and dollar. Then 2 on right parenthesis, 2 on right parenthesis, you have a reduction operation, that is reduce, s gives x. So on right hand side you have only one symbol, so 2 will be popped off, and you have 7 on top, so that is, you have to see, go to 7 comma s, s on the left hand side of this particular production, so 7 on s. So 7 on s, you have 8, so that is 8 here. So 2 has to be popped and 8 has to be pushed, so that is $0 3 4 7 8, and here it is the same, right? Now 8 on closing parenthesis, 8 on closing parenthesis, you have reduction using the fourth production, that is L gives L comma S. So reduce, L gives L comma S. So here we have on the right hand side you have 3 symbols, L comma S. So 3 symbols, 3 states has to be removed from here, that is popped off from here. So 8, 7 and 4 has to be popped off, so 3 will become the top. So now we have to find a go-to of 3 comma this left hand side, that is L. So 3 comma L is, you can see here 4, so that is 4 here. So it will be $0 3 8 7 and 4 will be removed. So after removing that, we need to push 4 here, so it is 0 3 4, and here it will be this one. So 4 on closing parenthesis, it is shift 6, so it will be here shift 6. I'll use this space here. So shift 6 means you have to push 6 here, so that is $0 3 4 6. Then this closing parenthesis will be gone, so that is on input it will be dollar. Okay, so this is one. So on now we have to see 6 on dollar, 6 on dollar, so that is 6 on dollar, you have reduction using second production, that is S gives open, L close. So this action is reduce, S gives this one. Okay, so on the right hand side you have 3 symbols, so we need to pop off this 3 states, 6 4 and 3. Okay, so once you pop off these 3 states, you have 0 on top, so we need to find the go-to of 0 comma the non-terminal on the right hand left hand side, that is 0 on S. So 0 on S you have 1, so that is 1. So 6 4 and 3 has to be pushed, popped, and 1 has to be pushed, so that is $0, these will be popped and 1 will be pushed, so 0 1, and here it will be dollar. So 1 on dollar, it is accept. Okay, so so as per this these particular steps, you have this string left parenthesis x comma x right parenthesis, this string with 5 symbols is valid, it is accepted. So the only difference with LR1 and LR0 and SLR1 is that in LR0 you will have reduction operations for all the terminal symbols across particular state. Here it is only for the follow of the particular reduction. Suppose R1 means that is the first production. So whichever is on the left hand side of that particular production, only the follow of whichever terminals on the terminals in the set for that follow of that left hand side of that particular production, only for those terminals you will have those reduction operation. So it is not across the whole thing, it is again restricted. You can say it as a restricted thing because you are say suppose for this particular example, for state 2 you are not putting reduction 1 for these two. If it was LR0, you could have put R1 here also, but instead you are putting only here 3. So here also in the across 5 you have only here for dollar left parenthesis and x, you don't have this reduction 3 operation. So similarly you will have a more stricter parsing table for SLR1. One advantage of this is like you will have less number of conflicts. So we haven't spoken about conflicts. Conflicts are the cases where you will have in a particular cell, so for a particular state or for a particular terminal symbol, you will have more than one action. That is, you can have multiple actions for the particular state, or you can have you have an error or something like that. So those cases will be minimized with introducing SLR1 passes. That's it with this SLR1 passer. So we have successfully designed an SLR passer for this particular grammar that we are discussing. Okay, thank you.